Okay, so we're going to be talking about gravitational potential energy. So let's imagine we had a large boulder that was sitting on top of a cliff. Currently in this position here, the boulder has a store of gravitational potential energy. And if I was to contrast another scenario here, where I had another cliff, but this time the boulder, was slightly smaller. This situation here also has gravitational potential energy. So if I call this A, and if I call this situation B. Okay, so we could probably hazard a guess that situation A, this boulder contains more gravitational potential energy than this boulder in situation B, but we need to be able to try and calculate this and also think about some reasons why. So first of all, GP, gravitational potential energy, is going to be equal to the height an object is held at. So in A, let's say for example, that was 10 meters, times the mass of the object that is being held at the height. So in this scenario, let's imagine that this is a boulder that is 5 kilograms, not a particularly big one, and then let's imagine in this scenario the boulder is 1 kilogram. And the height for scenario B, we will go with 5 meters. Okay, so there is another factor which comes into this equation, and that is called gravitational field strength, GFS. Now, the gravitational field strength on Earth is 9.8 newtons per kilogram, and often in tests and exams they can sometimes refer to it as 10 newtons per kilogram. So what does this mean? Well, it means, let's say for example, I had a 1 kilogram mass. If this was a 1 kilogram dumbbell, say for example, then I have 10 newtons of gravitational force pulling this 1 kilogram mass towards the ground. And that will change depending on what planet I'm on or the type of environment I'm in. Say for example, if I went to the moon, I would have slightly less gravitational field strength than this 1 kilogram object would be pulled down to the ground by less. This is just made up, but say for example 5 newtons of force per kilogram. Okay, so we're going to take situation B. We're going to pretend that this is happening on Earth. And situation A as well. So both of these situations are happening on Earth. Okay, so then we can go about trying to calculate gravitational field strength, the gravitational potential energy for the boulder in situation A. So what I'm going to do is I'm going to do my height, which is going to be 10 meters, times my mass, which is 5 kilograms, and then times my gravitational field strength, which is on Earth 10 newtons. So that's going to be 10 times 5 is 50, and then times 10 is going to give me 500. So 500 joules of gravitational potential energy. Okay, so now looking at situation B, see if you can just pause the channel and have a go at calculating this. So what we've got is we've got a height of 5 meters times our mass of our ball, which is 1 kilogram, times our gravitational field strength, which is 10 newtons per kilogram. And so that is going to give me 5 times 1, 5, times 10, 50. So that is going to give me a gravitational potential energy of 50 joules. And that seems to align with what we were suspecting earlier, that situation A is going to have a greater gravitational potential energy than the boulder in situation B. Okay, so then what I need to be able to do with this equation is I need to be able to rearrange it. So some people are fine with rearranging equations as they see them. However, some people might find that helpful to put that into a triangle. Now, if I'm going to put this as a triangle, I have GPE on top of my triangle, and I'll have height, mass, and gravitational field strength along the bottom of my triangle. So, therefore, if I wanted to calculate height, I'd cover height up, and it would be equal to what I have remaining, which would be gravitational field strength over the top of, so divided by mass times gravitational field strength. If, say, for example, I wanted to work out what gravitational field strength is, that would be equal to what is remaining, which would be gravitational potential energy divided by height times mass. And then if you pause the video and try and work out how you calculate mass. Okay, so hopefully you've paused the video and you've written mass equals gravitational potential energy divided by height times gravitational field strength. And then also, although we were given it and we will be given it in the equation sheet, gravitational potential energy, I covered that up. And I'm going to be left with height times mass times gravitational field strength. So now I know how to calculate these various different parts. I could go about answering any question in relation to gravitational potential energy. So let's say, for example, I am on some planet somewhere in the middle of space, and I have a situation where I have a boulder on top of a cliff, and I know that the gravitational potential energy in this boulder is 500 joules. I know that the mass of my boulder is 10 kilograms, and I know that the boulder is resting at a height of 5 meters. So what I've got to try and do is calculate the gravitational field strength. So if you pause the video and try and do this. So hopefully you've done that. I cover up gravitational field strength, and I'm left with gravitational potential energy divided by height times mass. Gravitational potential energy in joules is 500. Height in meters is 5, and mass is height and mass is 10. So that will be 10 times 5 gives me 50. 500 divided by 50 is going to give me 10. So I'm going to have 10 newtons per kilogram as my gravitational field strength. Okay, so I could also be given a question where maybe, say, for example, I'm asked to work out what the mass of something is. So let's imagine I've got a skateboarder here that's standing on top of a skateboard, and I am told that the height that the skateboarder is currently at is 2 meters. This is on Earth, so I'm going to say that my gravitational field strength is 10 newtons per kilogram, just to round things up. And I am going to say that this skater has a gravitational potential energy of, if we go with 2000 joules. So what I want to know is I want to know what the mass of this skater is. So I cover up mass, and I'm left with, so if you can pause the video and calculate this. Okay, so hopefully you've done that. That's GPE divided by height times gravitational field strength. Plugging in my numbers, 2000 is my gravitational potential energy in joules. Height is 2 meters, and gravitational field strength is 10. So 2 times 10 gives me 20, and then I will have 2000. So 2000 divided by 20 is going to give me an answer of 100 kilograms. So the skater is going to be, including a skateboard, 100 kilograms in mass.